Now, as we go into topic 4 of Unit 4, you're going to see the pulling together of lots of things we've talked about, counting and then probability. And the key word here is randomness, honesty, and chance. So let's get started. We'll start off easy. Now, here's your sample space. And as we look at it, there are 1, 2, 3, 4. That is out of 4. And we're looking that the spinner would land on red. So it's 1 out of 4, and that's the simplified fraction answer. Okay, we're going to give you an opportunity now to do a lot of this on your own. It's pretty straightforward. So we'll pause, and you want to set this up on your homework log, A through F, and then answer these questions. Again, a good review showing some simple concepts in probability. Now our numbers are 7, 6, and 8. 2 are even, so the resulting number is even, is our favorable outcome. So take a look at these, and if you have a question, be sure to let me know and we'll address it. And we want to review odds that we had mentioned earlier. Odds, again, it's favorable to unfavorable, while probability was favorable to the total sample space. All right, let's go on. All right, for number 3, this will be more challenging. Assuming that a boy and girl babies are equally likely, what would be Kathy's probability of having at most 3 sons if she were to have 4 children altogether? Now you may want to use a tree diagram to construct the sample space. So again, we have a sample space that we're going to make here. This will be a boy, and this will be a girl, and I'll start you off like so. And let's see what you can do. So to get started, again, I kind of jammed this up here, but we see how many individuals would you have altogether? Well, it's going to be a boy or girl, so there's 2 choices, and you're going to take it to the 4th child. So 2 to the 4th is going to be 16. So in your sample space out here, if you follow this along, you're going to get 16 possibilities. And let's get you started up here, and we'll see if we can make this first one. So boy, 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 boy. Boy, 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 boy. And this is going to take a while. So now you're going to go boy, 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 girl. And then let's continue with this and see how it goes. Well, I didn't give myself very much room here, so I'm kind of jammed up, but I believe I have 16, and they're all different. So now what we need to do is pick out what is the probability of having at most 3 sons. All right, let's see what we can count here. So we'd have it up in here. There's 3 sons, there's 3 sons, and there's 3 sons. And I believe that's it. So that would be 3 out of 16. So this one took a long time. If we only had 3 individuals instead of 4 children, that would have been a lot easier. For number 4, let's read it carefully, and you'll see we need to bring in some procedure we used in a previous lesson. So assuming that we have Jim, Bruce, Valerie, and Simon are 4 members of a class, and that 4 of the class members will be chosen randomly to deliver a report during the next class meeting. So what is the probability that Jim, Bruce, Valerie, and Simon are selected in that order? Well, first of all, we have to find out what's the permutation of this, because order is important. So permutation, how many in our group? 33. How many are we going to select in this order? 4. So we need to get that as a value to start with. So when you put this in your calculator, this is what you get. But that, in a sense, now is your sample space, and it's going to be 1 out of this. So they want your answer as a integer. Well, that's not going to be an integer. Or a decimal rounded to 6 decimal places. So we need to put that into our calculator and get an answer rounded to 6 decimal places. So a little review, when you put this into your calculator, you're going to get something like this, which is in scientific notation. So we need 6 decimal places. So we have 1. We have to have 5 zeros that we're going to add. 1, 2, 3, 4, 5. So when I move this, 1, 2, 3, 4, 5, 6, it becomes this. Now, another way of doing this to help with your calculator is just take this scientific notation and add 1 to it. Just go plus 1 and then disregard the 1, and it gives you the decimal point 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5. And this last one is going to be a 1 here. I put too many there. And then rounding it off, all of this just drops off, because originally there was a 1 there. Now when you added 1, but now you're not going to use that in listing it. So this would be the probability with the decimal points rounded to 1 place. Now if you'll need a little more help on this one, let me know, especially working with scientific notation. Now for number 5, this has to do with Mendel's work. He is considered the father of modern day genetics and was an Austrian monk and did work with pea plants. Now, some background, a round pea plant, as opposed to wrinkled, is a dominant trait, and wrinkled is a recessive trait. Now, when we have our first cross, which is purebred purebred round with purebred wrinkled, they all end up being round, but carrying the gene for the recessive. So when these are crossed, and we usually make a little Punnett square for this and sketch this in your homework log. If you cross these hybrid individuals, you end up with one purebred dominant, which is round, one heterozygous, we say, which is hybrid, which is round, another one as you fill these squares in, but you end up with one individual that is recessive, that is wrinkled. And I should have shown you this video on, in biology lab, the kinds of things we do when we make empirical counts, that is, by counting a sample of pea plants or corn kernels or Drosophila fruit flies, conditions of their wings, and other things. Now, mathematically, this is the theoretical result. We expect then 3 red, 2, 1 wrinkled. And I believe that's what they're asking here. So you would have 3 peas out of 4 that are round. Now in number 6, we are also dealing with genetics, where if you are a non-carrier of cystic fibrosis, the gene is dominant, not having it. If you have the gene, you have the for cystic fibrosis, it's recessive. Now, if you have at least one dominant, then you're not going to show the trait. But if you are a carrier, as this condition is described, you won't show it, but can pass the gene on. So suppose a child born to a carrier, one parent. So let's make our little Punnett square here. So a carrier would be big C, little c, to a parent that is a non-carrier, 2 big C's. So filling it in, what would be the answer to this? Well, the probability 2 of the offsprings would be carriers. So that would be 2 out of 4, or 1/2 of the offspring would be carriers. Going on now to number 7, here a particular disease is tested, and then 1 out of every 1,000 Indian families have the disease. 1 out of this many non-Indian families. But here we're going to be testing this many Indian females. So how many would you expect to have this particular disease? Well, it's going to be out of every 1,000, this many would have it. And I needed to add a 0 there. So in a sense, it's going to be 1 out of every 39. So since there was 39,000 tested, the number would be 39, would show this particular disease. Okay, we're getting close. A few more. Number 8. I like the ones that show color, easy to pick out. So she's randomly going to choose a ball from a can to the right. Find the odds against the event. Now that you pick out a red or blue ball, well, what do we need to do first? How many balls in the container? So there's 4, 5, 6, 7, 8, 9, 10, 11. Now, red or blue? There are 2 red and 4 blue. So to get it would be probability 6 out of 11. But they don't want that. They want odds against. So if we subtract 6 from 11, we get 5. And now we have to subtract the 5 from the 11 to get odds. And it would be 6. That it would be unfavorable or against the selection. Now, if they had said just picking out red or blue, that would be 6 out of 5. But they're saying against. So you need to be careful as you read this as to what they're looking for. All right, number 9. Here we know our probability is 59 out of 100. That's what they're saying. Find the odds in favor of E. Well, again, it will be 59, and then subtracting 59 from 100, you get 41. So matching this up is pretty easy if you know what you're doing. Now, notice 41 would be the probability that you would not get this, but that's not what they're asking here. They're asking what are the odds in favor, and you have to know the background for odds. Now for number 10, we have to dig into our tool bag. A trifecta is a particular horse race in which you pick win, place, and show. That is the first, second, and third place winners in their proper order. So first, we have to figure out and how many horses are in the race here. And here it is over here, 5. So order is important. So it's permutations, 5, and you're going to pick out 3. Now, when you put that in your calculator, and I'm going to do that right now, 5 permutation 3, I get 60. Again, that you're going to do that is going to be 1 out of 60. And that's the answer for number 10. And we have simplified the fraction. You can't reduce that anymore. Now remember, the permutation is 60. That would happen is 1 out of 60. Okay, that's probability. Okay, well, you're going to be doing your homework. And again, there's only 4 more lessons to go.